Good morning to everyone. In this class, today we are going to see about the introduction of design for manufacturer and assembly, and we are going to see what is design for assembly, and we are going to see what is design for manufacturing, and we will be seeing what is process capability, and with all those aspects we will be doing an analysis. That was a simple analysis. It is called as what? Worst case analysis, right? So what is DFMA? Design for manufacturer and assembly. So in earlier stages and all, already we are in manufacturing and already we are in design. And what is the need to change for the design into optimization? So actually the thing is, in olden days they have manufactured and they have did some prototypes and they have worked and they assumed that this prototype is correct, so we can manufacture according to this prototype. But present days we are not like that. So in present days we are following high level prototype. We are manufacturing then prototype initially, and we are making into test, and we are making design validation. So once all those processes completed, we are beginning into production process. So what is DFA? Design for assembly. What is the need for design for assembly? Already if we have any two matching components, just you think the example as nut and bolt. The nut and bolt has different structures, it has different diameters. So we have to assemble it and we have to fix it in somewhere, any type of engine component or any type of machineries. But you think it of optimization process. So in such cases we can eliminate the nut and bolt and straight away we can go for fasteners, we can go for rivets, so all those things. So in design for assembly, what we are coming to know, it is nothing but to optimize the process. Then what is for a design for manufacturer? So the design for manufacturer stands for all the components are manufactured in an automated way. So we can reduce the time and we can reduce the overall part production time. So this is called as what? Design for manufacturer and design for assembly. So what are the things it can be achieved? We can optimize the process. We can optimize the process and we can eliminate the wastes. We can reduce our manufacturing time. We can reduce our design validation time, and we can improve our quality, and we can go for mass production. So all those things are achieved by implementing design for manufacturer and assembly. So next we are going to see about process capability. So what is process capability? What it means? So it says that I have the capability to do this. I have the capability to produce this. I have the capability to design this. As like that in manufacturing process also, the process capability is nothing but each and every process will have a variation. So if suppose I have a shaft like this, and I have to assemble this holder here. This is the region it is going to be assembled here, right? So I am a manufacturer. I will manufacture this one individually and this one individually. I will be calling it as what? Part 1, and I will be calling it as what? Part 2. So I have a diameter up to 10 mm, and the assembly diameter is up to 3 mm. So always I cannot assume that this part will be matching under the same dimensions, and I will be having a depth of 2 mm length. So here I am supposed to give some tolerance. So in some cases I cannot manufacture the exact dimensions over here. So here I will be giving some dimensions as 2 plus or minus 0.001 mm. So by considering this tolerance, an operator or an labor, he can understand that I can give the tolerance plus or minus in plus 0.01 mm, in minus 0.01 mm I can give. So this is the applicable tolerance. So actually what it means, what is this plus or minus? Actually what it means in the sense, it means as what? Variation. So definitely it may be an automated or it may be a manual work, the variation will occur. So we have to calculate this variation and we have to provide the variation for each and every parts, right? So this is known as what? Process capability. The process capability is nothing but what? It is a measurement of the process. It is the measurement of the variation. So we have to measure the variation and we have to improve our variation, right? As like that, the design for assembly and design for manufacture is implemented to EC of work. What is EC of work? So EC of work stands for EC of assembly and EC of production. So both the things will be achieved by implementing design for manufacturer and assembly, right? So for now I will be showing some examples how the process capability is induced. And how the tolerances are given. So just you imagine this component as a stepped turning part. So let me draw this diagram. Right. So just you imagine that I have to give some dimensions over here. This is a stepped turning component. So for this stepped turning component, I have to give some dimensions. Without dimension, I cannot give the process chart to an operator or any type of any kind of labors. So here I am going to fix this as A plus or minus small a. Here B plus or minus small b. C plus or minus small d, D plus or minus small d, right. So what is this? The capital A stands for actual dimension. Capital A stands for actual dimensions. So we can keep the length from here to here as what? 2.5 mm. And we can keep this dia and then we can keep this dia as 10 mm. Therefore, this small a stands for plus or minus deviation. So here I will be giving the tolerance as approximately I am telling that. So when we solving the problem, we will be getting the exact tolerance. We have to calculate the exact tolerance. So I can give the tolerance as in plus and in minus, you may get 0.031 mm. So this is the allowable tolerance for your drawing. So as like that, for all the steps we have to give the dimensions. We have to give the dia and we have to give the length and we have to give the tolerance. Somewhere it is going to be mattered. Somewhere it is going to be assembled. So you think it of that assembly component. So that assembly component should attach or it should matter to with respect to this tolerance. Right. So this is what? This is a simple example of stepped turning parts where we are going to give the tolerances. Right. Then we are going to see about process capability analysis. So what is a process capability analysis in the sense? The variation will occur in each and every manufacturing process. We have to measure the variations. So with respect to that variation, we can obtain this is the expected time to finish this component. This is the expected time we can achieve the given tolerance. So as like that, we will be knowing the process capability analysis. Right. So just I am notating as PC. So here with a simple diagram, I will be explaining you about how the process capability is defined. So just we are going to see one example. How the bad coffee is manufactured. So who are the necessary persons involved in manufacturing the coffee? First one is what? material. Second one is what? Labor. Third one is what? Resources. Fourth one is what? Expectation. Fourth one is what? Expectation. Right. So here the material may be, now it is what? Bad coffee. So bad coffee in the sense how the material he will be choosing. So it may be an second rated quality. Right. How the labor should be? The labor will behave rude. So much examples are there. I will be telling just one examples to each and everyone. Right. So second rated quality material may be they may be using. Then his labor, he will be having any rude type of contact. Then resources. So he will not be no proper he may not have the proper equipment to serve the people, to serve his customers. And expectation. So the expectation will be fulfilled from customers' feedback. So this is how we are going to manufacture a bad coffee. So this bad coffee analysis to be monitored and it should be converted as a good coffee. We have to apply the process capability process here. Once the process capability process is applied here, we can identify the variation and we can go we can go to do an good coffee process. Right. So